little bit on medical research and epidemiology, also innovation and projects, something on central tendency and the measurement of dispersion. This measurement of dispersion, we need to do an experiment, then only it will be much better. So all of you can collect at least 100 data and then try to find out mean, median, and mode. Then we need to calculate both mean deviation and standard deviation. And then we'll be able to understand the difference. So this, you should remember that this exercise is to be done. Uh, and then today we'll be talking about probability presentation. And this probability of presentation, now there's a percent and probability. Probability is out of 1. The reason why it is out of 1, because the just like a kilogram or like a meter, etc., this is something which we need to apply anyway. So even in the case of population is 1,000 or 1 lakh or 1 billion, it is 100% and that is equal to 1. So probability is out of 1 and percent is out of 100%. So when we want to compare to population and the proportion, we usually talk about the 50% are this religion, 50% that religion, or 5% this religion, like that. In terms of probability, we talk of 0.05, zero 0.1, like that. So zero point 0.1 will be 10%. 100% is equal to 1. This looks very simple, but this comes frequently in statistics. And probability is defined as the relative frequency or probable chances of occurrence with which an event is expected to occur on an average. So, in short, we say that probability of occurrence by chance. P is the probability of occurrence by chance, not because of some reason. Usually, what will be the P in general? But if there is some intervention, it may change. And that change is by chance or because of some reason that we want to detect. So, for example, giving birth to a boy in first pregnancy, what are the chances like that? So, I had to come to some outside my home, and there will be some minor disturbances maybe there. Then, if you are giving one drug, what are the chances it is better than another medicine? Or what are the chances that today there will be rainfall? Chances of rainfall in winter, in the monsoon, and the summer will be different. So these are the chances we measure in terms of probability. And this, when we measure these chances, the whole question is whether the thing has occurred by chance or has occurred because of some reason. So if it has occurred because of some reason, we say it is significant. Now, these words, two words, by chance and significant, are frequently used in statistics, in statistical tests of significance, etc. When you say it is by chance, when you say it is by chance, it is equivalent to not significant. When you say it is not by chance, that means it is significant. So these words will come frequently. Now, usually we denote the probability as a P, and the lowest probability will be 0 and highest will be 1. It is almost equal to 0 to 100%. P is equal to 0, it means that there is no chance of an event happening or its occurrence is impossible. In normal distribution curve, usually we say that P can go near to the 0, but it never will be 0 in ideal normal distribution curve. That means in standard normal distribution curve. When P is equal to 1, that means it is 100% sure that this event will occur. Again, in standard normal distribution curve, P is never equal to 100%. Then, when you say there is a probability of occurrence of chance is P, automatically not occurring, that is a Q. So P plus Q are always equal to 1. And in binomial distribution, yes or no, we'll have a special formula to find out the probability. But if there are 4, 5 outcomes, like it can be a cure, it can be a death, it can be a worsen, or the status quo, something like that, then the binomial distribution will not work. And there will be multinomial distribution. And the probability can be calculated logically. For example, in you are playing the card, and one of the four essays from 52 cards means 4 out of 52. The probability is 1 out of 30. So 13 times if you withdraw the card, one time there will be S. So this is how the probability can be calculated. In suppose there are the container, in this there are 100 chocolates are there and hundreds are tablets are there. Both same size, everything same, and but then you are randomly picking up the probability that it will be chocolate or a tablet having the same shape, then you are blindly taking up. So it will be 50%. So we say that probability of having a chocolate is 0.5. Now, how do we calculate? Number of events occurring divided by total number of trials. If you are thinking that you are following 100 birds, out of 100 birds, there are 60 male and 40 female. Then you can say 60 upon 100. So zero point 0.6 will be the probability of occurrence of event, that is occurrence of birth of child. Surgeon suppose having a 200 cases kidney transplant, 80 are survived. So you can say that survival probability of survival is 80 upon 200, that is 0.4 is the survival rate. Similarly, you will have 5-year survival rates. Suppose out of the 1,000 patients of cancer, 400 patients survived beyond 5 years. We'll say that 5-year survival rate is 400 out of 1,000. That is 0.4 is the probability of 5-year survival. And in this case, kidney, what is the chances that a person will die? So 0.6 is the chances. Probability of dying is 0.6. Now, in this case, law of probability, additional law of probability. Actually, when you use a standard normal distribution curve, there are various columns. And various columns means you are adding the probability. That follows the additional law of probability. And there is a multiplication law of probability, in which if you say that what are the chances that both these occurrences will occur together, at that time, probability reduces, and that's why there is a multiplication. Any probability cannot be more than 1. It will be 1/2, 1/4, 1/3, something like that. That's why when you multiply the two probabilities, it will reduce. And when you add the two probabilities, it will increase. Generally, what happens if I do 5 plus 5, it will be 10. But if I multiply 5 into 5, it will be 25. So multiplication law in general, what we say that multiplying, that means more. But in probability, multiplying means less. This you will understand, provided you understand that probability highest is 1 and rest of all the lesser than that. When you multiply, automatically result will go down. In binomial law of probability, the result will be based on whether yes or no, or P or Q. Only two things are possible. At that time, we will have a binomial law, probability of occurring P or occurring Q, or how many number of P, how many number of Q, that you can apply over here. Suppose you toss the uh, coin, then one time, two time, three time, four time. Out of four, what is the probability that three times there will be the coin? Such when you want to consider in 100 experiments, then every time there will be chances of this or that. And how many out of 100 experiments, how many times there will be a four, all the four P or the coin, the king or cross? So that if you want to calculate at that time, binomial law of probability will be applied. Then we can directly find out from the normal distribution curve what will be the probability. Here, we are using the p-value. When we say that in using the normal distribution curve, when it is at the end, at that time it is so beyond that it is beyond the 0.5% together, then we say that probability less than 0.05. 5% is equal to 0.05. And we usually compare the probability with the tables. When we calculate the probability, there is a standard tables also available who which were uh, which are already calculated based on the mathematical formulas. So we need to compare the probability in the table and probability observed over here. Based on that, we'll compare what is in our case the probability of event occurring by chance that will be able to compare with the table. Now, additional law of probability that you can apply when there is a mutually exclusive events are occurring. For example, when you are tossing a coin, you will have either head or you will have a tail. So they are mutually exclusive. Both cannot occur simultaneously. So it is mutually exclusive. Or birth of a male child or birth of a female child. In this case, this or that. So these are the example of mutually exclusive. Or patient survived or patient died. Mutually exclusive. Right? And in both the things, event will occur in one or several ways because they are mutually exclusive. And they all have an individual probability or relative frequency of occurrence. These are the things where you can apply the additional law of probabilities. Total probability will be equal to 1. Suppose there are four things occurring. Patient has, we gave an example, right? The death, survival with the result that cured, survival but same, and absconded where we don't know the result. So four outcomes are there. But if we make a total of probability, each four of them will be 1, almost 100%. Thus, mutually exclusive events follow the addition law of probability. And if there are, let's say, I n events and pi is the individual probability, that means p1, p2, p3 like that. So total probability should be y. If there are only two possible outcomes, then p1 plus p2. If there are 10, then p1, p2, p3, p10. This is how we make a total and make it 1. And here, in additional law, the patient is having the person is having RH negative or RH positive. So RH negative or RH positive, total will be 100%. And here, if we want to have an example of additional law, right? Then we can say that what is the probability of we take a four category: the die, so the cured, not cured, and do not know. If you take this probability, then if someone asks you what is the probability that patient is cured or died, then individual probability will have to add, because here the word is or, so you are adding and increasing the total probability. Why? Because when you say the or, both can happen and you are considering that. Against that, in multiplication law, what happens? There is a word and, 2 and 5, 5 and 2. So if there are two separate dies, and what will happen in both the die? Here it is a 2 and here it has to be 2. Two separate events are occurring place, and in that also, what is result here? What is result here? So you have to multiply, and because it is n, the probability of occurring both event, right, by n together will be automatically less. So we are multiplying. When you apply the or, probability is increasing, and that's why you are doing adding. In this case, two or more events occurring together, but they must not be associated, must be independent of each other. When you are throwing a two dice, for example, both are giving an independent result. It is not that one is giving result and second is giving result like that. So there should not be association between two events. There you can apply multiplication law of probability. And here is an example where we can't apply this because, see, listen carefully. Out of 100%, 10 smoke heavily, and probability of getting cancer in heavy smoker is 1 in 100. What are the chances of being heavy smoker and getting lung cancer? Here the end. And if you multiply, for example, over here, then 10 out of 100, and this is 1 out of 100. So multiplication is says that 1 upon 1,000. That is only one person will get cancer as well as heavy smoker. This is not possible because the smoking and the cancer are associated together, and that's why here you cannot apply law of multiplication. If it is a different thing, then we can apply. If you have a separate two cats, 52 cards here, 52 cards here, in that case, if you say that, what is the probability that both will be having the black king? For both the black king, so you will be have 1 upon 52 multiplied by 1 upon 52. That will be the probability for both having a black king. But if you say, what is the probability that at least one will be the black king? Then here the what you apply that, or one, at least one out of two, say one should be this or that should be a black king. So 1 upon 52 plus 1 upon 52, that will be 2 upon 52, that is 1 upon 26. If you do that 26 time experiment, you will get one time that king. So similarly, you can think over that where if there is an and, then you apply the multiplication provided that and are independent. Right? In a law of binomial probability, there are only two things, P or Q. And that experiment you are doing many times, right? Many times you are doing that experiment, or that event, the sample size 1, 2, 3, 4, in each there is some event taking place, or there is some result. So in that case, the success or failure, and you have taken a particular sample size, then you go on adding your experiments, there will be question that how many times there will be P, how many 4P and 1Q, how many 2P and 2Q, like that. So in this case, suppose in ICDS, 4 ICDS projects, 20% of children under 6 years of age were found to be severely malnourished. In 4 ICDS projects, The word is four projects, right? Grade 3 and 4 is considered the minors. If only four children were selected at random from the four projects, four children were selected at random from the four projects, what is the probability of 4, 3, 2, 1, and 0 being severely malnourished? Out of four projects, all the four are malnourished. Out of four projects, three are malnourished. Similarly, no one is malnourished. If you want to find out this, then how to calculate this? P is 20%. That children are malnourished. That is point 2. And Q is point 0.8. And how many children you are selecting from this is 4. So I make a pause over here. You try to understand this, and I will continue this, but you just think on this. This will take some time. So this is you are supposed to actually in your setup you need to find out, and as an assignment you write down that you need to apply this kind of binomial law in your setup. Instead of four ICDS project, there can be four wards, there can be four batches of students, there can be four villages, there can be four the associations. In this, you won't have a particular number of people who are rich or poor or cured, not cured, or using some kind of the perfume, not using perfume, or they're taking a particular medicine, how many times they're taking paracetamol like this. So instead of four, you can have a six, the setups. From there, you want to have something like binomial, present or absent. Malnourished, not malnourished. Having spectacles, no spectacles. Having doing meditation, not doing meditation. Need to do this. And then when you choose a certain numbers, then what will the probability that you will have this kind of characteristic? So at that time, in this case, P plus Q is equal to N, right? So here P is equal to 20%, Q is 0.8%, and N is equal to 4. You are taking from the four projects, right? And four children you are taking on all the four. Suppose you are taking five children or six children, then N is equal to 6. Now, as per the terms of expansion of binomial expression, when you say that P plus Q is equal to, for example, 2. If N is only 2, then P square plus 2PQ plus Q. That will be the thing. And that is simplest, we know it. But when it's a 4 or 5 or 6, you may have to use mathematics. And this will tell you that the probability, right? Now, how frequently this will happen? This is what it gives. So, severe probability of all four being severely malnourished is equal to 0.16%. Here it is a 0.16% because point 0.2, P is equal to point 0.2, 0.2 into point 0.2 into point 0.2, like 4 times if you go, then it will be 0.16. So you can know that 0.16% children, all the fours will have severe malnourishment. Similarly, if you want to calculate that how many times three are severely malnourished and one is not severely malnourished. In this case, P zero point 0.2 into 3 multiplied by zero point 0.8 multiplied by 4, that you will get the event. This many times you will get that. So it is calculated based on that, the 3, 2, 1, 0, etc. How many times, right? So this will be shared with you, and in actual the uh, your setup, real setup, you should try to consider this. And when we use our calculator values and when there is the table values, we'll be comparing these two and then we'll give our inference. This probability simple looking things is the uh, main concept behind various statistical tests. Then will be, if there is any question, we'll take a question and then we go to the another uh, test kappa. Any question? You can unmute and then uh, ask the question, or at least in chat box, write the percentage you have understood. Suppose you have understood 100%, write 100. You can write anywhere between 0 to 100%. How much you understood about the probability, right between this, just to know that uh, about your grasping. That is 1% should write 70%. Then someone else, no one except Sandeep. No one is going to respond. Okay, it's up to you. I will be going to the next important thing. You all of you know that there's a lot of problems with the NEET exam. And in usually our theory exam, or what happens that two teachers are examining and there's a theory papers are there. And because it's a subjective marking system, can be disagreement between these two. So let us see the what test kappa does. Test kappa measures how much is the coherence between the two teachers, or two treatment, or two modalities of the treatment, etc. So coherence between the two, right? Let us do that. I'll be sharing with you a file, Excel file to you. I hope the screen is visible. I can get more size. I think this will be the good enough. Cohen's kappa measures agreement between two rates, right? Now here, suppose we take that when two clinicians are giving a diagnosis, there are two clinicians. One clinician diagnosis in the same patient, he says yes, other rater A. Rater A means clinician one says that, suppose there is a disease named the COVID clinical judgment, and this is a clinician two. Both says yes, in 50 cases, COVID person is having a COVID. And in 5 cases, there is agreement, yes, it is not having COVID. But when clinician 2 says, yes, it is COVID, and clinician 1 is disagreeing with that, there are 7 such cases. And in other things, there are 8 cases where clinician 1 says, yes, there is a COVID, and clinician 2 say it is not there. Now, in this, say, what is the agreement between them two? Is 0.37. This is kappa. Kappa is varying between 0 to 1. You can see as k is equal to 0, no agreement. K is equal to 1 is a complete agreement. So in this case, kappa is zero point 0.3. Now suppose there is another clinician 3 and clinician 4. In that agreement like this, in 50 cases, both say yes. In 40 cases, both say no. And here it is only 2 and here only 3. If this is thing, then the agreement between them 0.89. It is very good agreement between these two. This is done by the kappa. If some of you wants to understand what is the logic behind, then it is how to study this. So the formula of K is given over here, right? Formula for K, formula for PA, PE is also given. This is also given over here. And for this, yes, no, and probability of both yes and both no. So in this case, if you go into detail of this formula, automatically you will understand how this kappa is arrived. But we may not know how this car is running, but we should know how to run the car. So we need to use this cells together, and simple 2 by 2 table is you can generate through the epi info, and then you just add the figures over here and you will have a kappa score. In nutshell, it says that if the agreement is more, yes, agreement is over here, no, but both agree that these two will be a positive and though these two will be a negative. It is something like in chi-square test where we multiply with these two and then we divide by these two, something like that, right? So this is a kappa score. You can use it in 2 by 2 table for the agreement, or you can also use the word association sometimes. If here it is a variable which is the outcome variable, this is the input variable. That word is usually we use the word association, but this is equivalent to the agreement. So this is about the kappa. Any question on this? You will be able to generate 2 by 2 table and then use it. So remember, this is a coins. You forget the coins, you can use the kappa score. Even you can forget that, you can just say the agreement score. This is a simple, I will share you this file, and can you put these 4 figures over here, you will get the results. Then there is something like loss quality assessment sampling. I'll be repeating this again because this is not that simple. LQAS and very, very useful thing. Now, I think, is this visible? This file also will be given to you, and I'll be just giving the only overview of this LQAS. The actual example, you can do it when you have your own sample. Here, this is a ID number name of the village, population, there's a cumulative population, and there's a cumulative sample, and this thing. Now, in this case, this table, you need to, everything is ready, is given to you. The seat 1, seat test, seat 3, this is only for the purpose of your, if you want to do anything. But here, what you need to put your data. This is the data sheet. If you change this, and automatically you will get the output. This is a little bit programming is done so that you can have your data over here from wherever you are. And then this is data of your taluka, village list is there, or you can have a name of the school and number of the children. This you can copy somewhere over here, paste, and then automatically cumulative population will change. Suppose you want to have a desired sample size of 24, then automatically sample from where you need to take sample, 111 is written over here. From there, you are supposed to take a sample. Suppose you want to take a sample of 20 instead of 24, you want to have a sample of, let's say, uh, 12. Then you remember, see over here, it will change. Now it will moving over here. So this from which village or which lot you are going to take a sample, that you will get it over here. The lot sampling technique is very, very fast taking. In a short time, it gives a very good result. Only thing that you should keep only two things ready, a village and the population, or any things like a ward in number of patients, or schools in number of students, or association number of members, like this. You keep it over here, and automatically it will tell you from where you are supposed to take a sample. We'll be looking it at again. I will be sharing the file. You look at the file, and then uh, we should be taking the exact example. And instructions are very simple. I will read it for you so that it is re-emphasized. For drawing sample from a set of villages, suppose you have 100 villages, 200 villages, or 500 villages, you want to take a sample. For drawing sample from a set of villages, first delete any data in the village and population column. So you need to delete this data, right? Like this. And enter or copy paste fresh data into these two columns. When asked for a password, enter password. Usually, password is not used, is broken. So, suppose you have this many villages with you. This is your data. Let's believe like that. Lot sampling is very, very quick method, very useful method. It's just control C and very simple. Absolutely simple. And you just copy paste over here. And usually, how many samples you want to take? Take a sample size of 19. Usually, in this, we take a only 19 sample, and based on that, we find out whether the particular coverage calculator is wrong or right. So, first step is you copy and paste your list of population, unit-wise population over here. Secondly, in any sample other than 19 is desired, enter the number in the cell for desired sample using the sample password. So here, by and large, you should not change this 19. You keep it this because for lot sampling, 19 is an ideal thing, which is calculated. You need not do so many things. Only 19 individual will be sufficient out of, let's say, 10,000, 5,000, or even 1 lakh population. Only taking 19 individuals for a suitable calculation. Then the numbers that appear in the sample column are the number of individuals to be randomly picked up from the corresponding village. See, here it is in one. From this village, you need to take a sample. Here also there is a one. From this village, you take a sample like this. But this one person to be selected from 645 individual should be done randomly. It could be simple random sampling, or it could be the method which you are using in the cluster sampling. That also you can use. Find out the center of the village, and then find out the various the degree of the roads, right? The first, second, third, and the nearest road to how do you find out the random degree? Between 0 to 360, you take a random number that will give the random degree. And nearest the road is taken. And this is how you can find out that single individual. Even in the distance from center to the periphery, there is some distance. Let's say there is a 2 kilometers. Then from 0 to 2000 meters, you find out again a random number. Let's say there is 165. So 165 meters from the center on the particular road which was chosen, and the person staying near to that place point is to be selected as a random individual. So there are so many techniques which can be used for random. Now, uh, this can choose from 2,500 villages, because in this formula, 2,500 villages, for that the formula is given up to this 2,500 villages. So even if you have that many villages, you can use for that. Huh? Rest of the are hidden over here, and you can unhide the columns between C and F to see how it works. Between C and F, I have already kept it the open. Otherwise, you can hide this also. If you want to go beyond 200, if you want to go beyond this 200 villages, you have 5,000 villages, then you need to unhide this. This you need to unhide, then you will see the more rows. So I repeat, the lot sampling technique is something like from each lot. It was initially used in industries because industry can't afford to test each lot. So from various lots, few things are utilized and in a single specimen. And based on that, this reject the things. So remember, this is for rejecting the thing and not accepting the thing. And for rejection, when you want to find out whether to reject or not, so it is based on out of 19 samples, how many failed to certain criteria. Out of 19, how many vaccinated, not vaccinated. Out of 19, how many got the government subsidy, not getting the government subsidy. This is what it is to be done in lot sampling technique. So for that decision, whether it is 12 or 13 or 11, we use another table, and that is the decision rule table. This will be repeating next time because this is to be used frequently. Right now, people are not using frequently, but you should try to use it frequently. This is an rules for sample size of 12 to 30 and coverage benchmarks for or average coverage of 10% to 95%. So here is the sample size. Usually we should take a 19 as a sample size. 19 as a sample size. And out of 19, suppose this is you get 12. You get a 12 are having, let's say, vaccinated and 7 are not vaccinated. So in that case, you can say that the 75% coverage is maybe there. It may be there. But Suppose 7 are only vaccinated, then you can expect that coverage will not be more than 50%. So here, what is an average coverage equivalent? So by examining only 19 individuals taken by lot sampling, you can talk about the coverage in the population. This is why the lot sampling is useful. It's very quick and still almost precise to certain extent. Right? They have already given how much error is there in this. Right? So sometime we'll be uh, repeating this. Now we'll have some time for the question answer. And then I think by today I'll be sharing all the PPTs which we have talked so far. I think by tonight I will be doing. And then on Thursday we'll move further and we'll be going for non-parametric tests also. Meanwhile, you can share your concerns in the group also. Any questions, suggestions?
No, sir, no questions. Thank you, sir.
Yeah, no questions. You understood a bit,
Yes, sir,
Kappa
little
and
bit.
LQS. And also, next time, I think protocol, I will already share the protocol slide PPT today. And all of you should be ready with your protocols, whatever may be, and try to share in the groups so that all can look at it and then can discuss about it. On mostly on 9th July, mostly 9th July or maybe a little bit later, maybe a 4 5 days, evening session will start. So that also those who have not attending this session can join evening session. And there's no problem in joining after 1 year, after 6 months also. But we need to understand the probability which statistical test is to be used. Next time we'll be starting with examples that if this example, which statistical test you should be using. And that will start with a Z test. There are 5 types of Z tests. Each test when to apply, right? Standard of difference between two mean, standard of difference between two proportion, or standard proportion, standard of mean. All this will be utilizing. So that Z table and the test of significance will be using, and then we'll be switching over to the non-parametric test. Okay. If there is no question, I should stop it over here. At least one question you should be keeping ready every time. Every time. Hmm. Thank you.